Okay, what questions do you guys have this morning? Okay. So 5 over x. Okay, so there's our picture. We want 4 equal subintervals. The length, total length is 8, so the subintervals are each length 2. Easy enough to do that calculation. So the sides of our triangle are going to be at 1, 3, 5, 7, and 9. And it says we've got the 4 subintervals equal length. That's good. We're going to evaluate the subintervals at the midpoints. So the heights of our triangles, or sorry, the heights of our rectangles are going to be given by what happens in the middle here, which I don't have labeled. So we'll have to do something else for that. So this is at 2, 4, 6, and 8. And so the area of the rectangles is going to be delta x times fx1 plus fx2 plus ... Well, I just have 4 of them, so fx3, fx4. But this is x1, x2, x3, x4. That's where I'm evaluating my points. So this is going to be 2 times, well, 5 over 2 plus 5 over 4 plus 5 over 6 plus 5 over 8. So far, so good. Okay. Multiplied by 2, 5 plus 5 halves plus 5 thirds plus 5 fourths. So that's all twelfths. So that's 60 twelfths plus in twelfths, that's 30 twelfths, and in twelfths, that's 50. Sorry, that's not 30. Yeah, it's 30 twelfths. This is 20 twelfths. And this is 15 twelfths. Okay. So 50 and 60 is 110, plus another 15 is 125. So it's going to be 125 over 12. Which is as simple as it gets. Oh. Okay. That's the total area. This is total area. Right? what it wants is it wants the average value of f on this interval. So an average is what everything would be if it was the same, right? It kind of rebalances everything so it's level in some sense. So what I want to do is I want to find the line that I can draw horizontally here, where if I take this area and I stick it here, I just get a rectangle. So that this yellow rectangle here, let's make it orange. So I want the green area and the orange area to be the same. And if I do that, this guy will be the average f of x value on 1 to 9. Does that make sense? Okay. So how do I find that? Well, I take the total area of the green stuff and I divide it by the length, right? If you take the area divided by the length, you get the height. We want the length times the height to equal the green area. We have the green area. We're just going to divide everything by 8 then. So the average value on 1 to 9 is 125 over 12 times 1/8, because 8 is the length of that interval. 8 times 12 is 96. That still doesn't, so 125 over 96. And that averaging part might be what? Yeah. Okay. So let me write that out explicitly. The average value of f on AB is equal to the integral from a to b f of x dx times 1 over b minus a. Right. So I take the area and I divide it by the length of the interval. Right. In some sense, you're adding up everything that's adding up all of the function values and then dividing by how many function values there are. The integral kind of tells you add up all the function values and then divide by how many function values there are. Questions on that one? Other questions you have? Number 10. So we're doing the average value thing again. Okay. We'll estimate the average value for subintervals from 1 to 3. And it's just a function x squared. Oops. So 1 comma 1, 3/2, 9/4, 2, 4, 5/2, 25/4, 3, 9. But we're still supposed to be using the midpoints, it looks like. So we're going to have to find other function values in here too. But let's just do that later. So drawing my rectangles. Midpoint, 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 midpoint. And I want to draw a rectangle so that this area here and this area here are equal, right? Because if I make those two areas equal, then I can just move this area down to here and have my rectangle. And this is going to be my average value. Okay. And so I've got to figure out what the green area is first. Each one of these rectangles has width 1/2. So green area, one-half. And then there's going to be the function values at the quarters, right? This is 5/4, 7/4, 9/4, and 11/4, where we're going to evaluate those things. Good. And the function is the squaring function. So I'm going to take 5/4 squared plus 7/4 squared plus 9/4 squared plus 11/4 squared. Okay, so I have a common denominator on everything, which is 32. And then I have 25 plus 49 plus 81 plus 121. Because that's 5 squared, 7 squared, 9 squared, and 11 squared. Okay. Okay. 74, 75, 295, 376. Which looks like well, 188 over 16, 89 over 8. Yeah. 89 over 8. I think I did my arithmetic right. But there's always a risk that I don't do arithmetic correctly. Okay. Oh, plus I never divided by the length of the interval. That's probably why, actually. That was the green area. We want the average value. Average value. 89 over 8 divided by, what's the length of the interval? From 1 to 3, the length is 2. I got 89 over 16, not over 8. Try that. Okay, now my arithmetic's probably wrong. Okay, calculator. So 25 plus 49 plus 81 plus 121. 276, not 376. Okay. And so that makes this 138 over 16, which is 69 over 8. So that's is that right? That's 16, right? So you got 1/2, and then you've got 25 over 16 plus 49 over 16. And that's all multiplied. So really I have a common denominator of 16 over here, but I'm going to take it in half. So it's now a 32. For some reason, I'm feeling that like 69 is not the right thing. Like I took away 100 here and I divided by 4 twice. So I really should have taken away like 25 of whatever I had. So I'm thinking like 89 minus 25 is 64. Maybe I didn't do the original arithmetic right. 1836. Ah, yeah, this is 94. Okay, good. So now I'm happy with 69. 69 over 16. Okay, so better be good because this is my last check, right? Okay. Okay. Questions on that one? The arithmetic was a little rough, but are we good with like the process? Other questions you have? Okay. Okay. So let's try this one with the picture. So we've got a rectangle sheet with weird dimensions, but okay. The paper is placed on a flat surface. One of the corners is placed to the opposite longer edge and held there as the paper is smoothed flat. The problem is to make the length of the crease as small as possible. Call L the length, and we want to find the smallest L value we can. Okay, so it's given us this picture already. Let's draw the picture again and label a few more relevant things. So I'm going to take this point to this point. So if I draw where that moves, what happens is it gets folded along the perpendicular bisector here. So those are all 4 right angles if I'm going to fold it over there. We good with that? And so that and that and this makes a right angle here. Let me make sure that we see that this might not be through the top corner. Okay, so that's the picture we've got. Actually make that more solid because we folded that paper. Okay, and then it says X is going to be the length on the bottom that we cut to, or that we fold to here. So those two would be X, because the amount that you fold up has to be the amount that's there. This side is L. They tell you that this is the square root of L squared minus X squared, which, yeah, that's probably relevant. Okay. We want to find L squared in terms of X. Okay. So let's draw some more lines in here. Okay. I'm going to draw those rectangles in because I think that's going to help me find L squared. Why do I think that's going to help me find L squared? Okay, so let's label the rest of the picture. What's the dimensions of our page? 8.1 by 10.2. Okay, what I want to find is going to be this area here. And then once I have that area, I should be able to figure out what L squared is. Okay. So this length is 8.1 minus X. And this is 10.2 minus square root of L squared minus X squared. Okay. Maybe we could do this with some similar triangles too. Let's see. Too many possibilities. Okay. This angle and this angle are the same because this is just this triangle on the right. The white triangle is the flip of the green colored in triangle. So those angles are the same, right? And so whatever that is, this guy is pi minus 2. Let's call this alpha. Pi minus 2 alpha. And so I should be able to do some trig identity stuff here. So let's get L, X over L That's the, this is alpha. That's the adjacent over the hypotenuse for alpha, right? And adjacent over hypotenuse is SOHCAHTOA cosine. Cosine of alpha is x over L. Okay. And let's see. X over 8.1 minus x is equal to, sorry, nope, the other way around. Using this. The adjacent for this guy, 8.1 minus x over x, that's the cosine of pi minus 2 alpha. Good with that? Okay. That should give us enough to get this thing together now. Okay. So let's look at some trig identities. Here's alpha. If this is alpha, this is pi minus alpha, right? Let's go not alphas. Let's go beta. The cosine is the x value. So the cosine of beta is positive this, right? Then the cosine of pi minus beta is minus this, right? Okay, so this is the negative of the cosine of 2 alpha. And that's the negative of the double cosine identity is, I'm going to look it up because I don't remember off the top of my head. I can figure it out, but it's going to be faster if we do this. Right at the front of the book and from the back. Or maybe not. Trig identities. Cosine of 2 theta is equal to cosine squared minus sine squared, which is also so there's a minus on the cosine. That's minus 2 cosine squared alpha, and then that minus 1. So this is equal to 1 minus 2 cosine squared alpha. Are we good with that? Okay, so I got that x over L is equal to 1 minus 2 cosine, sorry, that's just the cosine. Okay, so I'm going to put cosine of alpha in here. So I'm going to replace this cosine of alpha with x over L. So we get that 8.1 minus x over x is equal to 1 minus 2 times x over L squared. Good. Here's this, right? this is equal to this. So this 8.1 minus x is equal to that. And I'm just going to replace cosine of alpha there. Yeah. Okay, I want L squared. So I'm going to move L, let's multiply everything by L squared. Actually, let's move the 1 over first. So rearrange things. 2 x squared L squared equals 1 minus 8.1 minus x over x. And so this will be an x here too. So you get 2 squared over L squared equals, well, that's interesting. Those guys cancel, right? Nope, that's not right. Because this is a minus both of those things. So I get a 2x minus 8.1 over x. And that's better. Otherwise, I would have something squared, which is equal to negative 8.1 over something positive, which would just be wrong. So x has to be more than half of 8.1. Okay, that's good. And now I can flip things over. Well, let's divide by 2. And then flip things over. And then multiply by x squared. And I'm kind of happy with that. See if this guy's happy with that. Should be. Two x to the third divided by 2x minus 8.1. There we go. Okay, where do we have questions on that part? That was kind of a mess. Oops. Big enough for you guys to see? There's probably other ways to do it, but this is the first way I came across. So. Everybody try it and find an easier way to do it? Or oh, okay. Instead of the double, they use the half. Maybe they labeled this angle alpha, and then this was half of that or something. if that makes sense. Or 2 minus alpha or whatever that was. Maybe they did that. You could also do the half angle, like you got this thing. They could have used the angle that was up here. I don't know. Depends on which angle they picked. You could probably do it with the areas like I was starting to think about, with the green stuff matching areas, but the trig stuff might be the easier route. So one of the powerful things with the trig stuff is every time I was going to write down a square root whatever, right? I can just write down a trig function instead, right? Instead of using the Pythagorean theorem on all these diagonal type things, you can just use trig ratios. And then those trig ratios sort of can carry around that Pythagorean identity inside of the trig identities, which are sometimes easier to work with. And then it was just, well, I've got this expression and it's in terms of cosine of alpha. I have what cosine of alpha is just by x over L. So now I can replace it. I can get an expression from just the x's with x's and l's. Okay, what's the rest of the problem? Okay, just like when we were doing the distance stuff, to minimize the distance, we can minimize the distance squared. So here, I want to minimize L. Well, I'm just going to minimize L squared. Okay. So we'll take a derivative. So 2L L prime is equal to, here I got to use a quotient rule, 2x minus 8.1 times 6x squared minus 2x cubed times 2 over 2x minus 8.1 squared. I want to set the derivative equal to 0. So I get 2 times L times 0 is equal to this whole thing, which will expand the top out. I've got 12x cubed minus 48.6 x squared minus 4x cubed over 2x minus 8.1 squared. So that 0 makes this entire side 0. And if I cross multiply, I can get rid of the denominator by moving it over, as long as I make sure that the denominator isn't equal to, well, as long as x isn't equal to half of 8.1, 4.05, we're going to be good. And so I've got 8x cubed minus 48.6x squared equals 0. So 0 equals x squared, 8x minus 48.6. So x equals, factor out an 8x squared. Times x minus 6, 8.1? No, 48.6 divided by 8. Which would be 6 and 3/4, a tenth of 3/4, or 3/4 of a tenth. Okay, so 6.3 X equals 0 or X equals 6.075. So I don't think I need radicals. Let's just put in 6.075. Okay. And if I put 6.075 in up here, I will get L squared. So I'll take the square root of that. And it wants an exact answer. So let's type all that in. It doesn't like that. Okay. 2 times 6.075 to the third divided by 2 times 6.075 minus 8.1. Okay. All right. Questions on that one? A is probably the hardest part of that. Yeah. It takes time, it takes practice to see what to do with the picture, these geometry pictures. And really, you're just trying to write down all the relationships you have between the variables. You can put in more variables for things that you can label on the picture. Like we put in an alpha for the angle, and then we found some other relationships between other angles to that alpha. But you're trying to label all the relationships you can and then see, okay, which ones fit together nicely so that I can get what I want out of this picture. And that just takes lots of practice and some time. And that took us 25 minutes to go through the whole thing. And that's me doing it and sort of struggling through it a little bit. But it's some of these optimization and picture problems, they're like a good puzzle. You just have to spend some time with it. You can't just put the puzzle together right away. You have to first find the corners, find the edges, and then start filling in the middle. So labeling everything is like finding the corners and finding the edges, and then getting it all fitted together right. That's the harder part. Might have time for one last question if it's a short one. Okay, we'll move on to 5.2 tomorrow. 5.1 is due today, right? 5.2 is due Friday, or is it? Okay, 5.1 is due Friday. We'll have some time to go 5.2 then too. All right, I will see you guys tomorrow.